All right, today we're going to look at that reverse crossover so that we can name ionic compounds. Okay, and one of the methods we'll use is actually the reverse crossover. Okay, all right, let's take a look at a few. So we got MgBr2. So we're always going to look at what we have. So I'm going to go to my periodic table and I'm going to find my two symbols. So when I have Mg, that is actually magnesium. Yeah, my cat's helping. Magnesium. Then I'm going to find Br, that is bromine. And when you look at both of these, there's really nothing special about them in terms of their combining capacities, right? Magnesium only has the one combining capacity. Bromine only has the one combining capacity. So there's nothing that we really need to add here other than changing the ending. So this is magnesium, and this is bromide. We change that ending. Okay, let's try another one. We have FeCl3. So once again, I'm going to go to my periodic table and I'm going to find these two symbols. So I find Fe, that is iron. I find Cl, that is chlorine. Okay, now there is something special here about iron. If we look at iron, we can see that it has more than one combining capacity. Iron is actually +3 and +2. So we need to determine which one we've used. This is where that crossover method comes in. So I'm going to just rewrite these down here and then separate them out a bit, and I'm going to cross over. So right here it's understood that there's a 1 here. So let's cross that one over, and that's going to go up here with chlorine. I'm going to take this 3 and I'm going to cross over to be up with the iron. So now I go to my periodic table and I check chlorine. Chlorine is in fact -1. So that looks good. Nothing has been reduced here. So we are then using the 3 for iron. So our final answer is iron. I got to tell everyone I'm using the 3, so I'm going to use Roman numeral 3, chlorine. Now chlorine we change to chloride. So that is iron 3 chloride. How about this? Na2CO3. All right, so what is different here? Well, we have 1, 2, 3 capital letters. So with 3 capital letters, this is telling me there are some polyatomic ions here. So let's go ahead and see if we can find these. I'm going to look on my periodic table. I can actually see Na, that is sodium. Now C and O3, I want that whole thing together. Usually your polyatomic ions are at the end. There's only one that we really need to memorize that would ever be first in our compound. So we have sodium, CO3. I go to my common polyatomic chart and I can see CO3 is carbonate. Carbonate. All right, so let's check sodium. Sodium only has the one combining capacity. Sodium is +2 and carbonate is -2. Sorry, that is incorrect. Sodium is +1 and carbonate is +2. So no, the real thing is only one combining capacity for sodium. We do not need any Roman numerals here. Let's just rewrite this. Sodium, and with the carbonate and with all polyatomic ions, we do not change their ending, so we leave it as carbonate. Okay, let's try one more. We have Zn and then in brackets OH2. So the big hint here, in addition to the fact that we have 1, 2, 3 3 capitals, is we also have these brackets here. As soon as you see brackets, that should be the big hint. We got polyatomic ions here. And it's even telling us this is the ion that we're going to find from our chart. So I go to my periodic table first, and I'm going to find my Zn, and that is zinc. And then I go and find OH. OH is hydroxide. Zinc only has the one combining capacity, so again, no Roman numerals needed here. I just need to name the metal, and in this case, name our polyatomic ion, and because it's polyatomic, we do not change any endings. It is zinc hydroxide. All right, so that's just a little bit of naming. Keep practicing. This stuff is not easy. Later on this week, we will start looking at molecular compounds.